Yeah, sure.
Yeah, just mute yourself because some noise is coming. But could you just think of, why you got rejected, or what might have happened wrong? Like, what was there in the last round?
Yeah, actually, um, I don't know. Like that interview was basically there is no HLD LLD questions were asked in
Okay.
last round. It was only that they said it will be a small like coding round
Okay.
on the basis of Java 8. Like it will be revolve around Java 8 only. So I prepared accordingly. But initially, eventually he has asked some more questions about
Okay.
the Spring, like how Spring internally works, the
Got it.
framework, Spring framework, right? It internally works, and so at that point I got confused because my main focus was Java 8 only, and so I feel like
Got it. Got it.
I have asked them to provide me a detailed feedback as well, so that I can just check out what are the weak points. But
Got it.
yeah, that's what
So
it is.
there's this one thing that I like to focus. I'll just mute
Mhm.
you again. You can maybe see about your noise that is coming. Like, if you can mute it somehow, mute that noise somehow. But yeah. So the issue is that the way that I have seen interviews go is that the interviewer will first try to either ask something, right? Either they will try to ask you questions based on your domain, like they want to see if you're like a domain expert, right? Because in companies how it works is there are two kinds of people, right? One person who is doing this HLD LLD, the mapping kind of thing, one who is good at that, and the other person who is actually doing the hands-on implementation, right, who is good at that. So that's how a team is made, right? A good team happens is a combination of these two people. One who is very low into that language, who can know how to optimize on the language, and the person that can optimize on the upper level, right, who can come up with the architecture and stuff, right? So the reason that the interviewer is focusing on that part of it is because like maybe it's because you have said that that is what you want them to focus on. But like the way at least I keep interviews is that I tell them to focus on the more on the HLT and LLD concepts, right? The first round is obviously a DSA round. That is something you cannot avoid, and that's kind of luck, I feel like. If you have seen the question, you'll be able to do it, else you will not, like for an average coder like me or you or anyone else, right, who are not that good at DSA. But for HLD and LLD, right? So if you tell them that this is my specialty, I've built multiple systems over the years, they will ask you questions on that, right? So again, it's totally up to you, right? One high recommendation that I like to give is that try to keep your resume, right? Keep the skills that you're really good at on your resume. If you're not good at something, don't try to include it or include it below, so the interviewer can ask you questions on that. And also try to do a very good intro, right? When you're doing an intro, try to focus on that this is something I'm good at, or just tell him that this is a specific thing that you have done. So you can steer that interview in your direction. But okay, so we'll talk more about that in the one-on-one after this call, right? Right
Sure.
now, right now, I just mute you. Yeah. So right now, I just want to do the four design patterns, that creational design patterns, right? So we'll just start, right? So today's the first lecture on design patterns, and I just kind of wanted to tell you guys. So do any of you guys know what a design pattern is? Anyone? Hello, Khushbu, Alok, Mrityunjay.
Yeah, Ramit, like in very layman term, we can say like how we choose to design our application on the basis of certain concept,
Okay.
like something like this.
Sure. So I'll again mute you. Yeah. So basically, what a design pattern is, right? So you write code, right? There are a lot of ways to write code, right? As a programmer, and if you want to perform an activity, right? What is programming? It's an activity that you are trying to perform, right? So there are multiple ways of doing that activity. Like if I want to tell you, I just I hope I'm visible, right? So if I want to tell you that, you go from this corner of the room to that corner of the room, or you go from here to there, you can do it in multiple ways, right? But some of the ways are right ways, right? There are roads, multiple roads that lead you to a destination. Now, some of those roads have, well-defined roads. They are good roads, right? And some of the roads are bad roads, right? Like you do that, your programming complexity is going to increase. It's going to become more difficult, right? So I think in 1900, 1980, or 1990, a group of these engineers, right, they created this book that was very popular. That said that, okay, if you want to do this activity, right, you do it like this, right? So they structured it into design patterns, common things that we do in programming, right? So what are some common things that we do in programming? Like we create objects, we reference objects, and have functions, we perform activities, right, in our system. Whenever you're writing code, you do these activities. So that's kind of what design pattern said. It says that, hey, imagine a Jira ticket, right? Your manager has assigned you a Jira ticket, right? So what you can do is, you have this design pattern, right? So you see that what design pattern will that fall in. Now you know exactly what code you have to write, right? And you write that code. So it's like, basically, instead of like your manager, how is he like saying, you write code, right? It might conflict with your manager, right? He might say that, I want code to be like this, and not like the way that you have written. This might create trouble down the line. So if a design pattern is implemented across an organization, what happens is everyone's referencing the book. You know what kind of PR comments can come. You know what can be the issue with writing code this way, because it's kind of like a bible of sorts, right? I wouldn't say that, but it's kind of like a common thing that these engineers, they're very experienced engineers. They have written code in a lot of ways, and a lot of ways have failed, but they have found that if you write code this way, if you use these patterns in your code, if this is the way that you're defining an object, if this is the way that you're doing this, then your code is going to be successful. Then you are I mean, your system can scale easily. You can perform a lot of these activities easily, right? You can do what you want to do, basically. So that's basically what design pattern is, right? So I'll go a bit about and tell you guys about creational design patterns, right? So again, there are various types of design patterns, right? What are the types of design patterns? There's creational design patterns, there's structural design patterns, there's behavioral design patterns, right? So just three types of design patterns, right? So today, like what they do is, whenever, what is it, when you're trying to create something, right? You're trying to create something, an object or something, you use the creational pattern. Structural pattern is whenever, I think it's for the adapter pattern, bridge, composite. Again, different use cases, right? For behavioral, you have this behavioral pattern. So today our only focus is going to be on the creational pattern. We're going to understand this in depth. We're going to understand all the use cases of it. We're going to dig into docs, right? Let's All the docs that I've referenced, like this doc, all of that we're going to see. And at the end of this lecture, I want all of us to be on the same page with the creational design pattern, right? uh, so we'll start, right? um, let's start with something simple, right? What is a singleton pattern? Do any of you know what is a singleton pattern? Yeah, just unmute yourself. But
I don't know voice. I'll try to fix it. I'm not able to hear it, but I'm not sure how it is disturbing. But yeah, I'll try to fix it.
okay.
So for single data design pattern, something like this, when we create an object of the class, that object should be only single object should be shared across the application. Whenever someone, like some other service or something, try to access that object, it should return the same object rather than creating a new object.
Definitely, that's one definition. That's a good definition. Yeah. So what happens is, let's just say, right? Let's try to talk about a real use case, right? Let's not go into code and understanding. Let's just say that you have an application, right? You have an application, and there's a let's just say you have a database, right? You have an application and a database. I'll just try to write this, right? You have an application. This is your app, right? And you have a database, right? Database. Now there is a rule. Now let's say your database is a very small database, right? It's a T3 micro, or kind of a test database. Let's consider a condition that at any point of time, right, uh, you can either write into the database or you can read into the database, right? So you guys will agree this is a real kind of situation that can happen, right? That you have a server, there's a lot of operations happening, but at any point of time there can only be one database operation that is happening, right? So uh, again, just mute me if just interrupt if you guys are not understanding anything, right? If you don't interrupt, then I'll understand that you're understanding everything, right? So when this kind of thing happens, right, you have a data, and basically, so you want this database, like you have multiple threads that are running, but you want that there should only be one copy of the object that is able to access this database. So whenever it's accessing the database, you can just put a lock on that object that, hey, I'm accessing this database, don't so there can be multiple copies of that application that goes out, right? That database, but you are just passing that database object itself to all those copies, right? So this is a kind of a real use case uh, of the singleton design pattern, right? So now I'm going to look at the code here that I've written, right? And then I'll again go back to that example, right? So see, this is a singleton class that I've written, right? And then you have this singleton name, right? And then you have this instance private static. So can any of you tell me what this static means? Anyone?
Object to call this or access this.
Yeah, exactly. So this static means that for this class singleton, right, there is only one instance. You can create multiple objects of singleton, but this instance will be one, and that instance is going to be shared across all the singleton objects that you're creating. See, I'm creating two singleton objects, singleton singleton 1, singleton singleton 2, but whenever I'm doing this set instance, right, uh, single, and I'm doing a get instance, you can see that if I am setting 2 to b and I'm doing a get instance of 1, right, what is happening? Let's see what is happening, right? Because if you see live example, it will be clearer, right? See, a b, so I am setting b, but I'm getting when I'm getting it, right? So if I create two objects, and if I'm setting the second object, I'm doing a get instance on the first one, I'm getting b. Why is it? Because all of the there is just one copy of this instance that is being maintained across all the class. So it's a property of the class in itself, right? And see, whenever I'm changing the value, I'm not doing a this dot instance, right? I'm not doing a this dot instance because it is not a property of the object. So if I'm making multiple objects from it, it's not a property of that, it's a property of the class, right? It's a property of the class, that's why it's coming as singleton dot instance. So only one copy is being shared, right? Now I'm coming back to this real example that I gave you guys, right? This is a database, this is an app, right? Now within my app, let's say I have um, certain classes, right, that are doing a lot of functions, right? um, Poll user, this is doing something, this is a API 2, like I'll make it more term, right? API 2, this is API 1, right? So they are doing uh, activities, right? And within this and for each of this, right, I need so let's say API 2 is doing some activity. It's storing, it's pulling some value from Redis, it's updating the database, and it's sending back the value to the user. So I need this database instance for all of them, right? I need it for API 1, I need it for API 2. This database is needed for all of them to interact with the database, to interact with the Postgres database that I have, right? But I want to ensure that whenever I'm sending to one object down to this API 2, right? So this API 2 is a class, and this database object is a dependency, right? Whenever I'm sending this to this API 2, I need to ensure that only one database is executed. Only one database call is executed at a given time. Now these two are running on, separately, they are running on different threads, right? So how do I ensure that? That's why I pass a common object, right? That's why I make common values within this database, right? And I like write it like that. Maybe it could be like a flag or something. So there are certain but you can think of instances yourself where you might have to use a singleton design pattern, right? So is this example clear to everyone, or does anyone have any questions on this? Clear to everyone, right? Just do a thumbs up if it's clear to everyone. Okay, this is great. This is great. I'm happy you guys got it in the first try, right? And the point about the design pattern is not about learning the design pattern, right? I mean, you can mug it up, but what's the point of mugging up a design pattern, right? At the end of the day, it's about, you will be getting a Jira ticket, right? And your job is to understand this Jira ticket and understand where do I use this design pattern, right? So that's where, and why is this very important in LLD? Because if you get an assignment, right, they want you to tell them which design pattern you have used and why have you used that design pattern, right? So if you are using this design pattern, if you're using this factory design pattern, or if you're using this builder design pattern, you need to tell them that this is the reason I've used. So that's why I'm focusing a lot on the reason for using a design pattern, right? So the next design pattern that we are going to cover, right? Which one did we go? We covered the singleton. Now the second easiest design pattern, which is the prototype design pattern, right? Prototype design pattern. This is a problem that I had in a company, right? We had a JSON. Okay, this is again a real example that I'm giving you guys. And since I'm giving real examples, so you guys should understand that why design patterns are so important, right? We had a JSON, right? And A is B, B is let's say it's a deeply nested JSON, right? It's a deeply nested JSON that we have, right? C is D, like this, right? So it's a deeply nested JSON. Now we have functions. Okay, we have functions. Let's say we have a set function and we have a get function, right? Get function, right? So this get function will get you this, right? And this set function is going to set some value in here, right? Now let's just say that there is some logic, right? There is some logic that I have to take this value, right? I have to take this value, and somewhere in my code there is this use case that I have. There is this business use case that I need to make a copy of this, right? So I need to make a copy of this. Now what a programmer did was just do this, right? He did this just, right? I don't know if this was, but OB, right? He just did this, right? Can anyone tell me what is the issue with this? Hello?
It won't copy the nested properties. Like it's,
Exactly. So
yeah.
it's going to copy the nested properties, but it's not going to do a deep copy, right? So what is it doing? Basically, it's copying up to one level. For the second level, if I am taking this OB copy, right? If I'm taking this OB copy, which is this, right, and I'm changing it, and I'm changing the value of C to E, right, then my A is also affected, and this is causing a memory leak that becomes not memory leak, but this is causing a trouble that is, very very big issue, right? So that is why we use patterns, right, like prototype pattern, right? So I'm going to explain this prototype pattern. We'll see the code, but then you guys have to tell me that what is a use case where you can fit this kind of pattern in, right? In general, if you're given a problem, right? So the prototype pattern is a very simple pattern. If you look at it, right, there's a prototype function which is called the clone, right? So we are not delegating the logic of cloning outside the class. In the class itself, they have a clone function, right, which is basically just going to return a clone of the object, right? So if this kind of issue happens, right, that this is happening, that you clone something and then you made a change in the clone and it affected the original object. Why did this happen? Because someone who was using this object tried to put that logic there, and it is untested, right? So instead of that, if you're doing this, right, and something breaks, then you know that it's breaking because from here, from the class itself, right? So if you do an object dot clone, you are secure, right? Because even if it has a very deep JSON object, nested JSON, when you're doing an ob.clone, the calling function is rest assured that no matter whatever is in the prototype, I'm doing an ob.clone. Now I can take this clone and I can do whatever I want to do with it, right? Because it has cloned. So there is this trust that is also coming here, right? So if I run this program, right, Java. So I'm doing, and again, this code is all available, right, at the common GitHub repo that we have. I'll share that in the group. Sorry, Java concrete prototype. Okay, sorry, this is not the class, I think. Okay, the class is prototype. Yeah, so the original prototype is prototype 1, and then we have this clone prototype. Now you can do whatever you want with this clone, right? Instead of you taking that logic yourself, might be there is some JSON in this, right? Might be some deep nested JSON is there. Now if you don't have this clone function, now you have to make sure that it all works. And now you are not the guy who has created this class, right? So you don't know all the details that what might be there inside this class. Maybe this class is also not exposed to you, you cannot see that file, right? So now you are safe. You just do a clone, and now you know that all the data has been moved, and I can safely, the clone is in a separate memory. It has no relation with the original, right? So original, after modifying the clone, is, you can see that I have changed the clone, but the original is still the same, right? So does anyone have any doubt on it so far? Like we did, I think we just did 2 design patterns, right? Anyone has any question, anything to say?
Ramit, I have one question. Sorry, but I'm little confused about it. Like only overriding the clone method, by only overriding the clone method, how come it will copy the nested JSON as well? Like, sorry, I'm
No.
confused. That's why I'm asking. Like,
Yeah. So
explanation.
the clone method, you are not overriding the clone method. So what is happening is, if you see in this clone function, right, you are writing all the logic, right? You are writing all the logic, if you see, for cloning this object, right? So if there is a deeply nested JSON here, right, if I have here I have just a string field, right? But if I have a deeply nested JSON here, so inside this clone function, I can write all that logic for a deep copying the JSON, right? So I can do like string dot convert to string, then convert from string to JSON, so that so that that this code, right, if this is my class, and if I have tested this class very very well, because I know it's going to be used everywhere, all the objects in my repo are going to use this class. So if I have tested this class very well, if I have tested my clone function very well, that then I can expose this class to my entire repository, right? And anyone else can do anything with it. They can just do an object prototype dot clone, and they can be rest assured that the deep copy is happening, because I have written this logic inside this clone function, right? If I did not do that, if I did not have a clone function, then how do we do prototype clones, how do we do clones, right? We basically do a new concrete prototype one, and then I'm going to do a prototype one dot field equals to prototype 2 dot field, right? And I might make mistakes, right? Calling functions might make mistakes, and then the results are incorrect, right? But if it's in the prototype, then it's safe. Does that make sense?
Got it, got it. Now I got it. So like we are providing the copy of the object with the like uh, extra functionality, what we wanted to do with the object.
Exactly.
Uh,
So we are
uh,
what we are doing is we are exposing that class itself is giving a clone function, that if you want an exact clone of whatever we have, but with no memory location issues, right? Because like no memory, separate memory, but exactly the values will be the same. So you use your clone function whenever you have to do a clone. Don't go around doing things by yourself, right? So that's when we use a clone function. Okay. Now,
got it.
yeah, I hope everyone gets it. If you're getting it, just drop a thumbs up, right? So that I know that all of you guys are getting it, right? I mean, we're just 13 people, right? So you can unmute your mic and talk also. But that's good, that's good, right? So two more functions left. Now it's going to get a little bit harder, right? But use cases are not always simple. Sometimes it's a bit more difficult, so you have to be used to it, right? So this factory and this builder. I think builder is more easier than factory, right? So we go to builder, right? Let's just say you have a burger, right? You have a burger has lettuce, wraps, and all that stuff, right? You want to build this burger, right? So how can you do it, right? Now I have this burger, right? And within this burger I have bun, patty, cheese, veggies, sauce, right? But I cannot expose this and make this public, right? That because if someone is doing a new burger, he can put like 100 patties in there. He can do bun equals to 100, bun equals to 500. So this is also something that something to learn, that whenever you are creating a class or something, never make the uh, what do they call these? These are called, I think, data types. Never make the data types. I don't know what this is called, but I don't remember. But never make this public, right? Because people instead you are always
Data
supposed to
members.
what?
Data members.
Yeah, right. Sorry, I forgot. So data members, never make these data members public, because if you make them public, then the calling function can literally tamper with it, right? That is a very bad practice. If you're doing that in an interview, don't expect a call, right? But you either have a constructor, or you have, for each data member you will have a getter and setter for that purpose, right? That both are ways to do that. But if you're doing this is a builder pattern, which is very interesting and useful, right? So if you have like a class, right, that is like this, right? And you have a builder, so you want to build a burger, right? And so you don't want to initialize it all at once, so you can have a constructor, right? I can do a constructor here, where I'm putting like this, just like this, right? Bun, sauce, like where I'm initializing the whole thing all at once. But what if I want to do something, where I have the order, right, but it's not complete yet, right? Let's just say you're designing an e-commerce, you are designing the McDonald's screen, right? You're designing the McDonald's screen. So it's always a possibility, right, that you start with an empty burger, you add sausage, patty, filling, and then you save it and you go, right? So your object is incomplete at the point, and then you come back again and you add the remaining until your pattern is until your burger is complete. You add the sauce and veggies, right? There might be optional and all that. So that is where you create the builder pattern. So try to understand where is the real life use case where this kind of pattern might come, right? So you create, say, burger, cheeseburger, new burger, builder, right? You return a empty copy. This builder is going to return you an empty copy, right? There is an empty constructor for that, which will return you an empty copy, and then you have this burger dot builder, and then dot bun is a function, right? So this gives you an empty function, and then dot bun will add a bun, dot patty will add a beef, dot cheese will add a cheddar, right? You want to stop here, you don't add all this, right? Then dot veggies, dot sauce, and once you have added all that, dot build is going to build you the burger, right? So if all of if you don't add some of them, you can it will still build, right? As long as essential components are there. If they are not there, it will say that, hey, the burger is not yet complete, right? But the this is the pattern, right? This code, this is how you organize code. What's more important is that when what are the real life situations where you are actually going to put this builder pattern, right? And get some extra marks in an interview, right? Because there are multiple ways to do this, if you can think of it, right? Let's just say I'm going to build this, right? Burger builder demo. So I can have a constructor, I can have getters and setters for all of this, but just imagine how the code is going to look, right? First is I can do this public, but that's not allowed, right? um, Second thing I can do is I can do a setter and getter for the bun, patty, cheese, and all that, and then I'm going to do a cheese a set, right? But if you do it like this, it looks better, right? It's more clean and organized, right? So under this kind of things where you have multiple, so if you have multiple variables, like multiple data types or like that, right? And you want to initialize them. There are some that are mandatory, some that are not needed, right? So you use this builder pattern, right? Does that make sense? Yeah.
Yeah. So does that mean if I if I suppose I forgot to add any of the ingredient in the burger will not be created. We are restricting to the user to creating a burger like if any of the ingredient is missing.
Yeah, so that is
It
totally
will
up
throw
to
an
you.
exception. Okay.
Yeah, so you can choose that, maybe I can have a burger without a patty, or maybe I can have a burger without a cheese, right? But I cannot have a burger without a bun. So again, I have not written a lot of logic in here, but if you see how it's working, right? New burger dot builder, right? You have this builder function here. Where is it? Public builder sauce. Then you have this sauce, bun, patty, right? You have this builder function, right? So new burger dot builder, which is within this class burger, and dot bun, so it's adding the bun, it's adding the sauce, it's adding the cheese, and it's adding the patty, and when it's ready I do the build, which is going to return me a burger with all these ingredients, right? If I miss any of the ingredients, it you can add logic here that if patty is null or something like that, then you don't return the, then this class is incorrectly initialized, right? Then this object is wrong. So you don't return it, right? You only return it once it's all done, right? Does that make sense?
Yeah, so in the current scenario, whatever snippet we have, it will create. Although bun will be not there, also in that situation, also it will create the bun
Yeah,
burger. Right?
it will
We
create
haven't put
because
any condition.
yeah,
Huh?
yeah, yeah, it will create because I have not written any kind of if else, but um again, because I want it to be very simple for you guys to understand that where do I implement this, because if you know design patterns but you're not able to implement them, then there's no point in knowing design patterns, right? So whenever you are getting a you see like this kind of situation where you're getting a lot of this data types or whatever they call it, right? And you have a lot of them, and they are all needed in a certain sequence for this, right? If you have a situation, let's say that you have so many data types, but you need all of them to be initialized for certain things to happen, right? You need all of them to be initialized, then you don't do this. Okay, you don't do this. You write a simple constructor that takes care of it. But if you have a situation like this, right? Where I want the bun to be initialized, I later want to choose the patty, I want to choose the cheese veggies, like that, right? Maybe 1 2 are needed to be initialized, 3 might not be needed, or I can initialize 3 later on, right? I can initially have the bun and patty, and some functions can work, right? A print burger can work, right? If I just initialize the bun, I can do this function. If I initialize the patty, I can do this function. So that way, you don't need to write plenty functions for that. Use this builder pattern in those cases, right? So this is very clear to you where you're going to use this builder pattern, right? Just
Yeah,
underline. What
yeah,
are
one more thing. Hello.
Yeah, yeah, I got it. You have any
Yeah,
questions?
yeah. So if setters and getters are there in constructor and there, so why we make it them private? So we can access directly, right, via setters and getters.
Why setters and getters?
Yeah, via setters and getters we can access those private members directly, right? So why we cannot make them public
Yeah,
instead
because
of private?
that's the yeah, because inside a setter and getter you might not see any code right now, but in a production environment there's always going to be some constraints that we are going to define inside the setters and getters. You cannot just like it might not be as easy, right? Again, that is also a kind of pattern, right, that the interviewer will see. You never make it public, because that means that any calling function can do anything with it, right? Let's just say it's your balance, right? You have written a function for your payments, right? Bank balance, let's say class bank balance you have written, right? And you have made the bank balance public. Now I am calling your function, and I am making your bank balance negative. I'm putting it as equal to -2, right? Now that is a problem with you, right? I'm using your object and I'm doing something with it that is not allowed, right? So that's why you never make it public. You always use setters and getters, right? And you define constraints within that, even if there are no constraints, right? Even if it's just a simple logic, that is you're setting it as equal to this, or you're getting this, then also you put setters and getters, because the next engineer, because it shows the interviewer that when you're writing that code, right, you're not just thinking about today. Tomorrow an engineer will come, and he might have some logic to write, right? He might have to put some value in that setter, or set some constraints now, right? So just think how difficult his job is now going to be. You have made it public, all the functions across the org, um, across the repository, it's scattered, and they are all using that directly. Now he has so much headache to do, right? That's why when you start writing also, even if there is nothing to do, you always use setters and getters. This is something you need to hard code in your brain, right? Make sense?
Yeah, yeah, yeah. Okay, thank you.
Yeah. So these are something that you absolutely have to do. This is the, like, if you're doing a take home assignment, right, the interviewer is like, he sees that you have made it public, or you have done some hacks there, here and there, he it is going to be a very negative point, right? um okay, so we did this third pattern. So we have done 3 patterns so far, and I hope that any if anyone has any doubt, just interrupt and tell me that I'm not able to understand this. And this is not we did prototype, we did singleton, we did builder. Now coming to the more difficult one, factory, right? What is a factory pattern? A factory pattern is basically, let's just say, right, I have two objects. I have like a circle, I have a rectangle, right? And let's assume a situation, right? You have money with you, right? You have money with you. You have $30,000 with you, right? And you go to a car dealership, right? And you want a car for yourself, right? You don't know what kind of car you want, right? The car dealership, like, you go and you give him $30,000 and you tell him, give me a card, right? So he can give you, like, for so what the car dealership will do is, he will see that, okay, you have given him $30,000, this can afford a cyber truck, so he's going to give you a cyber truck, right? If you came to him with $10,000 and you gave him $10,000, the car dealership will give you something else, something that is worth $10,000, right? So that is the factory pattern, right? There's a factory that hides all that, all the so the object creation is hidden from you. You are passing parameters into that factory, and that factory is giving you back an object that is basically like what do I say, so based on whatever parameters you have passed into the factory is creating an object and it's giving it back to you, right? We'll see the code a little bit, right? Try to understand this code. There is an interface shape that has a void draw function, right? Now you have a class circle that implements shape, and within which, how you guys know how interfaces work, right? Everyone knows how interfaces work. Just drop a thumbs up. Okay, since no one said they don't know, I'll assume that everyone knows. Okay, so you have this interface, and then you have a class, that a class circle that implements this interface. You have a class rectangle that implements this interface. You have a class square also that implements this interface, right? Now we have a shape factory, right? You have a shape factory, and then this shape factory is getting the shape type, right? Now if shape type is circle, it's going to return a circle. If shape type is rectangle, it's going to return a rectangle. If it's square, it's going to return a square. Else throw illegal invalid shape is provided, right? So you do not initialize a circle, you do not initialize a square. All you do is you take the shape factory, right? Shape factory dot get shape. It's a static function, right? So you don't initialize the shape factory also. For you want a shape, right? You just do shape factory get shape and you pass the shape and it's going to give you back the function. So shape one does not know if it has got a circle back, if it has got a rectangle back. He just sent this thing, he sent this circle. Maybe he's talking in code, he's sending one, and here I'm doing one. So he's talking in code, he doesn't he just knows he needs to give this code to here and he's going to get something, and then he's just going to draw, right? This is the most used design pattern. This is used in every application that we build, right? As a good developer, do you know why this is used so much? um, okay, no one's saying anything. So this is used so much because interfaces, right? This abstracts away the details, right? So whenever this function is calling it, right, it is just concerned with the shape one dot draw. Let me talk about a real use case, right? You want to send an SMS. Okay, you want to send an SMS. There are multiple SMS providers. There's Gupsha, like there's Kaleda, there's maybe Times Internet, a lot of SMS providers. Your application wants to send an SMS. It does not need to know how that SMS is going. It does not need that logic that is going to overload its brain, right? what so what it does is you create this shape factory object, right? And it sees, and within this shape you pass it the metadata of the message itself, like is the message very long, is the message a priority message, and within that shape factory, within that message in factory, you can define that logic inside, right? You can define that if the message is very long, then we send it like this, then we use Times Internet, which is a low cost thing. If it's an OTP, then we'll use a provider that is good with OTPs, right? So that logic does not need to go to that logic is it's very specific to that to the SMS, to the person who is handling that SMS. It does not need to go to the other person who just wants to send an SMS. He does not need all that headache, right? That how SMS are sent. He does not need to figure all that out. That's why it's the most popular design pattern. That a lot of people use this design pattern without even knowing that they are using this design pattern, right? Because senior engineers have coded like this and they're just copy pasting the code. But this is used everywhere. You go and inspect your company's code, you will see this design pattern everywhere, right? This is because this isolates all the logic, right? This isolates all the logic, even for test cases, right? You can just pass a pass a flag, and that inside that code, that it will determine that it needs to go to a test case, right? So is this factory pattern also clear to all of you guys? Okay. Okay, so that was kind of the design patterns that I was going to cover, right? We'll have like a um, like let's have a short Q&A, right? Does no one have any doubts on these design patterns that we have discussed?
Yeah, hi, Ramit. I had a question regarding the builder pattern.
Builder pattern, yeah. Tell me.
So suppose there will be many requests coming, right, for the like for creating the object. So
Okay.
suppose for each request, we need to make a different build for each request.
Yeah.
So how will we design that or code that?
For each request, you need to create a different build.
Suppose one person needs only just patty, one person needs everything in it.
Yeah.
So for that one, like how will you design it?
Just like I've designed it, right? If someone needs just the patty, right, you can see I've not put any checks here, right? So if someone needs just the patty, someone needs just the cheese, you know, if someone needs just the patty, I'm removing this, right? This build will still run, right?
Okay, so like we'll have to then we need to have different constructors for that, or get a set or and set as will do.
No, that's the point of the builder pattern, right? You don't need multiple constructors. See, you can modify this build, right? So how this works is, say, dot build is building this function, right? So you have this dot bun, right, that adds the bun, then dot patty that adds the patty and all that stuff, right? So you can add it later also. That's the point of the builder pattern. If you
Okay, we'll keep the mandatory builds in one constructor, and then later on we'll just add it
Yeah, yeah,
upon the request.
yeah, exactly. That is a good way to do this. But if you're using the builder pattern, again, yeah, that is a very good way to do this. You add your mandatory builds in the constructor, and whatever are optional, you put it below, so that you know,
Okay.
you can, maybe you create an object, right, at a
Mhm.
point A, and now you need to reference this object at a, like, you will add, like, you created your burger, right, and you added at a patty at step 1. Now you want to print that burger, and you want to add the cheese at step 2 after printing the burger, right? So your object is created, you use that object a bit, right, where whatever it unlocks some functions. When you added the patty, now you add the cheese, it unlocks a few more functions. Now you add the this other thing, it will unlock a few more functions. That's way,
Okay.
you know, you can use that function as you can use that object as you're creating it, right? That's kind of
Okay.
the USP of the builder pattern, right?
Got it.
Yeah. No more questions, or does anyone else have any questions?
That's it for me.
Okay, cool. Um, okay, that's great talking to you guys, right? I hope you guys understood. Drop some feedback maybe of the session, right? We'll again have the next one, I think, on Saturday or something. Yeah. Okay, bye guys. Have a great day.
Thanks. Thank
Thank you,
you.
Ramit.
Thank you.